Hello geometers, and welcome to the continuing series of videos on formulas of familiar objects. Now we are going to talk about the area of a triangle. And I wrote this formula down already. That's what this theorem basically says, is that the area of a triangle is 1/2 the base times the height. What we're going to spend most of our time dealing with here is proving or seeing why this is true. Okay, and so I'm going to start out by drawing a triangle, and I'm going to make a scalene one, and I'm going to make sure that it's not a right triangle, because that would make it way too easy. So when you're finding or doing proofs, you want to prove something true for the most basic, most generic, most difficult shape, because if you can do it for a difficult one, you can certainly do it for a simple one. And we know that this is typically called the height or the altitude, and then this length right here is called the base. Okay, and we have to show that this is somehow 1/2 the area of this blue triangle here is 1/2 the base times the height. Now, if you notice, the area of a parallelogram is the base times the height, and the area of a triangle is just 1/2 that. So that suggests that somehow this triangle is nothing more than half of a parallelogram. So the idea to this proof, the idea is to make a parallelogram out of the triangles. Okay. Now we can't just say that, we have to describe exactly how it's made, but it's not too difficult. Let me name this A, B, C. And so this is what I'm going to do. I am going to take my ruler and draw a line that is parallel Okay. So I'm going to take a line and make this parallel to AC. And I'm going to draw it however long AC is. I'm going to make this line of the same length. So let's see. Make or construct BD so that it is parallel to AC and equal to AC. Okay. So I have these line segments here that are congruent and parallel. Then I'm going to connect D to C. Okay, connect D to C. Okay. And now let's compare this. Let's look at this shape. My claim here is that ABDC is a parallelogram. Okay, and I'm going to show that's true in the following way. Okay, so I'm going to show that the two triangles are congruent. Triangle ABC is congruent to triangle DCB. Okay, and it's not very hard to do. First, we know that BD is congruent to AC, because that's given. Okay. And we know that BC and BC here are congruent. Because it's the same thing. It's shared by both triangles, so it's reflexive. Okay. And we can go one step further and say that these two angles here are congruent. Okay. So 3. I'll call this angle 1 and 2 to make it a little bit easier. Angle 1 is congruent to angle 2 because of alternate interior angles. Okay. So that means the two triangles are congruent. ABC is in fact congruent to DCB by side angle side. Okay. You have a side, you have an angle, and then a side in the middle here. So now that that we figured out that's true, there's all kinds of other things that we can say. So one thing that we can say is that these two opposite sides here must be congruent. Okay, so we can say that AB is congruent to DC by CPCTC, and so or ABDC. So now you have this picture where the opposite sides are, these two opposite sides are congruent, and the top and the bottom opposite sides are congruent. So that means this must be a parallelogram. Okay. So its area is equal to the base times the height, equals to AC times this height right here. Okay. But the original triangle that we had, triangle ABC, is just exactly 1/2 of the parallelogram. I'm running out of space here, so I'm going to write this on some extra paper. But triangle ABC is half the size of the parallelogram. Okay. So the area of triangle ABC must be equal to 1/2 this base times the height. Okay. So there you have it, a proof, a justification for a very familiar and useful theorem and formula, that the area of a triangle is really 1/2 the base times its or the base times the height divided by 2. Okay, because all triangles are just parallelograms, and all parallelograms are just different rearrangements of a rectangle. Okay, so if you look at the video for the previous proof and this one, the ideas connect together. If you want to find the area of a parallelogram, you make a rectangle out of it, and you show that the parallelogram and the rectangle are the same. And then if you want to find the area of a triangle, you take the triangle and try to produce a parallelogram out of it, and show that the triangle and the parallelogram are just the same thing, except parallelogram's bigger. It's twice as big. Okay. As always, ask for help if you need it. Thank you for watching, and have a wonderful day.